So this is
our
sensors. We put this in our case, so you can see in the.
Hey, one quick question: are we recording this?
Yes.
Okay. And can you announce who you are when you speak? Because we don't necessarily see you speaking.
I'm Javier, and this is just like last presentation. We just have the sensors here. We had GPS, the ESP, the accelerometer, and the LoRa. Oh, the LoRa is not in this one actually.
It's not on the pictures yet, but it is on the final.
Yeah, it is on the final one. It's not on these pictures. And that all goes into the case that we made. This is our alpha prototype of the case. It basically features, like, you can see on the bottom left the dimensions of the case. And here, let me go over here. Can you see this? I'm on the table.
Yeah.
Yeah, I think I zoomed in over here. So this is the case. Originally, we had side clamps that go down and then clamp on the side. But for our first prototype, it was too tight and it wouldn't fit. So that's why we had to cut it off. And this lower hole, it was a little bit off center as well for our first prototype. So we had to cut it a bit as well. But other than that, we had this same clamp idea for the collar. You just slide it in, and that worked pretty well.
Actually worked pretty well.
Yeah.
Did you say the holes before?
For the LoRa antenna, sorry. This hole on the side is for the LoRa antenna. Then we can open this.
Yeah, we can.
And then inside, you can see all the sensors that were mentioned on the last slide. The GPS is on there, and then instead, here, let me switch slides. So you can see the accelerometer and the temperature on the side there, but they're actually underneath the GPS on this one to conserve space. And then the LoRa is right here, and the ESP, of course. And then over here we have a power boost.
We just lost the audio.
I lost audio too.
I think I hit the OK by accident.
Yeah. It doesn't matter.
Over here, you can see the and not zoomed in yet. Okay. So anyways, on the side there's a power boost, and there's a switch right here to turn the device on and off. And underneath all this is the battery, just goes right here. And again, the dimensions are on this next slide. It's about 90.
I think the left side has more information.
Okay.
I think.
Either way, if you here, I can just go into the actual. I'll just do it after the presentation. I have the actual file in Fusion 360. But anyways, we use LoRa's to transmit our data, of course, and LED shows if the LoRa radios were or weren't transmitting, and he can show that too. And we just added one to see if the LoRa that was connected to the ESP that was connected to Wi-Fi was actually connected to Wi-Fi or not.
Yeah, so with data transmission, so we have the two parts right here. One is the collar itself, which I'm assuming you can see. I have no idea where the camera's pointing at. Yeah. Awesome. Okay. So this, as the collar, as it's assembled right here. Then there's this base station that I assembled. It's on a breadboard that is what's it called? Glued to this battery pack so that we can walk around in the field. We can just attach it and walk around simply like this. These are connected together via these LoRa antennas. There's a LoRa transmitter as we're installing here. Here's this antenna on this breadboard, and they're communicating in LoRa. So originally, how we set it up is that this just gives a broadcast, and we hope that this LoRa caught it. But we during testing yesterday, we found that to be a little problematic at times, just because depending what this LoRa was doing or what this ESP was doing, if it missed that broadcast, it would have to wait another round. And so actually yesterday evening, I implemented a receive confirmation so that this sends a packet along with a unique ID string to this ESP. This ESP receives it and it checks if it has seen that unique ID before. If it has not seen it, it takes the request and forwards it through Wi-Fi to the database that Carly created. We'll talk about later. And then it receives a confirmation that it has received that unique ID string. And if the caller does not receive a confirmation that whatever packet was received, it will send that again in a certain amount of time. Right now, I have it set to 750 milliseconds. And it sends it again. But say the other issue that we could arise is that even though if this received the initial message, but the caller did not receive their response, and it would double send a message that has been already received. For that reason, this ESP stores the past multiple ID strings. It stores 3 right now at this point, which is good enough for the timing that it's set to. And even if it receives a duplicate, it won't forward a duplicate onto the Wi-Fi or to the database. Instead, it will just send the confirmation again without actually forwarding it on. So there's this handshaking going back and forth to make sure that the message actually gets across and it's not lost. And so I tested the functional range yesterday, and if this LoRa on here, if both LoRas have an antenna, we could get consistently about 200-300 feet with these LoRas, and whenever we take off the antenna from this transmitter, we could get about 100 feet relatively consistently. Today that I've implemented the handshaking, that distance is almost doubled to about 400 with both antennas. And if the caller does not have an antenna, it could do 200-250 feet because of the handshake, because it would actually make sure that the message gets across instead of just broadcasting it once, shouting it, and hoping that this receiver received it. So as kind of Kamir mentioned, there is these LEDs. I have no idea how well they come up on camera. There's a green, red, and yellow LEDs right here. Whenever the red is lighting, like right now, that means that it hasn't received communication in more than 10 seconds. Obviously, that's a very fast timer for calling a caller offline, but that's just because our testing is over the course of 30 minutes instead of months. There's a green LED, which flashes twice if it receives a successful, transmission. And the yellow LED indicates if there's an issue with the Wi-Fi. So if I turn off Wi-Fi off my, on my phone right now, I can actually go ahead and do that. Then every time we receive the LoRa messages, and because we won't be able to forward the message further on, because we'll receive, basically the yellow LED flashes, there's the HTTP code other than 200. So now that Wi-Fi is off, next time we have a message, which should be in the next 5 to 10, there you go.
I can see the yellow flash.
I don't know if you caught that, but there was a yellow flash.
Yeah.
And so, yep, there it was again. Mm-hmm. So that's what happens. The yellow and the red flash together. The yellow indicates Wi-Fi. So if yellow and green blink together, that's a successful Wi-Fi code. If yellow and red blink together, that's a Wi-Fi issue. So I thought about putting a LCD little screen here with I2C, but that would have been a lot of implementation and figuring out what strings to display and so on. And these LED statuses are just, it gets the point across right now for what we're doing. So that's the transmission that we have right now set up.
Okay, so I can talk a little bit about our data processing output on the server side. So unfortunately, a couple hours ago, I was working on the website and I was trying to add graphs as a feature, and something went wrong, and I accidentally broke the website. So unfortunately, I won't be able to do any kind of live demo tonight, but hopefully throughout all the stuff you'll be able to see throughout the semester is a pretty good indication about what it would have looked like tonight had that accident not happened. And we also have images as well of basically what happened as well. So essentially what happens in this project, as most of you already know, once the data comes to the receiving ESP32 through the LoRa, it then transmits an HTTP post request through Wi-Fi. And then that request is received by an EC2 server, and then that data is processed and then put into an AWS web database, and then eventually that data is displayed on a website for researchers to see. So as you can see on the right side with those images, in the top right you have the table that would essentially display on the website. So the way the data was broken down is you would have the time that the sensor recorded the actual measurement on the collar. Then you have the time that the server would actually receive the data from the collar, so we could have that, I guess, distinction, especially like when packets might be delayed later on in the actual field. Then we have the type ID, which is essentially the type of measurement. So for example, we have 1 and 2, which are latitude and longitude, and then finally you have the value, which you can see in the far right column. And then there were also buttons up there, which would essentially sort the data depending upon the type. So example, if you press the temperature button, all the temperature data would display on the website. And then above the table, we had a Google Maps element, essentially, where we were able to display the latitude and longitude data that we recorded in the field, and also the directional data that was associated with that latitude and longitude. I know those pictures are small, but we have them blown up in later slides, so we'll be able to get a better picture there. So yeah.
And the other day, we put the color on Carly's dog, actually. And we went, and that's what, if I go back on the...
You can go forward.
Oh yes, right. That's what these GPS signals are getting at. So one thing to note is that in between, you can see in the middle of the picture where it's like, there's grass, but it's kind of like brown because there's not that much grass. We actually walked straight in a line, and it didn't pick up any of that. So, what was the reason?
I mean, it's hard to say what the exact reasoning was, but I think a lot of it had to do with the fact that either we stepped a little bit too far away or something else, or it wasn't direct line of sight, because the caller yesterday was only sending one packet transmission and calling it good. It wasn't confirming that the receiver has actually received the message. I think we just lost those packets just because there was no communication at that time. So after that, that's when I established the two-way yesterday confirmation.
But it did work, and data did go to the website. That's what these points are telling us.
Also,
Maybe the dog was super fast.
Guys, when traveling on this, were you going from the building to the other side towards the tennis courts, or in the other direction?
So we went from this parking lot down here up, and then to the tennis courts, and then we went back.
Okay, I'm just wondering because I see power lines through the middle. And I wondered if power lines might have interfered with your signal.
I don't think there are power lines in the park.
There is power lines right here. I didn't notice them, but
I didn't notice them either.
Yeah, I mean, maybe.
I guess that is a possibility.
Yeah, we hadn't considered that.
To be fair, if a bear is out in the wild, this may or may not be a concern.
It's interesting. You walk both directions, and it missed the data both times.
Well, after we came back, something happened inside the case, and we couldn't get any more data.
Ah, okay. Yeah. Thank you for that, because otherwise I'd really be challenging.
Yeah. And
Well, but Mark's correction of the handshaking was done after this experiment.
Right. That was one for today's experiment, which is
Yeah, there's another data.
We did 2 test fields.
Yeah.
So the second run was today morning. If this video loads a little bit, it's gonna be laggy. But so this is the breadboard, and I don't know why it's so buggy right now. But we attached the collar to the dog canvas, and we took a UTV around a large property. They own 38 acres, but their neighbors has a massive farm with hundreds of acres. So we just kind of drove around, had the dog following us, and it was broadcasting, transmitting the whole time. Oh, cool. You can't. Yeah, this video doesn't really do the point across, but we'll see here in a second. So yeah, the dog had the collar on it. It was perfectly fine. It didn't care. The collar didn't bug it. I mean, this is a what's it called? It's a domestic dog, so it's more used to collars than a bear. But at least it shows that this kind of a collar works for dogs. We're able to create a dog collar at least. So, and that's the dog just chilling there with the owner. So here is the data. If I don't know if there's a laser or something, or okay, actually, do you see the mouse? No, probably not.
Oh,
Yeah,
there's
you can see the
a-
mouse.
Oh, you can see,
Oh, you can't see the mouse.
it's just laggy.
Yeah, it's there.
Okay, so right here where the pointer is, this cluster of data is where we started. And you can kind of see, so the arrows actually are pointing in the direction of the compass of where the dog was facing at that time, or where the collar was facing. From here, we went around this path a little bit, and you can see the how the like the arrows lead us around here. Right here, where there's a cluster, I actually stopped to open the website on my phone to make sure that it's actually being broadcasted, and so there's a few dots accumulated in one spot. We went back around right here to the dog house, and you can see that there's a lot of points in all directions as the dog was doing dog things. We drove over here up a hill and just drove around up this hill again also with the dog running around us. And so there was a fairly significant altitude change between where my cursor is now and up this hill. We actually haven't looked, I looked at the data just scrolling through it, and the GPS did pick up a change of almost 30, 40 meters. So I realize that altitude is a very inaccurate measurement from GPS, but it was noticing a change. So you could tell that it went up and then it went back to the same thing plus or minus a meter to where we started. So
Cool.
So it's actually fairly reliable.
I noticed that there's some of those positions showing the direction showing 90 degrees. How do we attribute that, you suppose? Did you notice that?
Where?
Follow the path from the hill where you said the rise.
This one right here?
So it looks like going up, for example, the dog would face
There you go. Yeah.
in a different direction there.
You're not-
Actually, he was running.
Well, I think they went up and then came back.
Right, so
But-
the going back, it seems like that was clear from going.
Yeah, going up seemed to be a little ragged.
But it,
Yeah. Again, so part of that has to do with the fact that the compass is sandwiched in a small case with a battery and everything else with all the electronics. I don't know how reliable a compass like this for $5 is.
Were you,
Whereas
was
like
that the
this-
actual compass reading or is that a reading of direction from the GPS?
No, that is the magnetometer that's in there.
Okay.
Okay.
It's reading the what's it called the heading between 0 and 360. Yeah.
I mean, dogs don't always face in the direction that they're running, so the head's probably going back and forth.
Yeah,
That's
but
a
this one
big
had
part
been
of it, too.
sidestepping, right?
Also,
Yeah, but I wondered if maybe, if he picked it up right, but he was kind of looking over his shoulder.
first that, and second of all, the compass is technically supposed to be exactly parallel to the surface of the Earth to get correct readings, and that practically never happens. And
Yeah,
so,
sure.
if the collar say is picked up at a certain degree, the left and right or the magnetometer is offset by a certain amount, which is not at all being accounted for. So
It just looked a little unusual. I
yeah.
didn't mean
It
to
is,
challenge.
I agree.
You know, I'm kind of used to using GPS direction. And,
Right.
and normally you don't see that kind of disparity.
Right.
That's cool. No problem.
Yeah, I noticed that actually in some of the earlier other measurements.
Yeah.
The direction, it didn't always exactly coincide.
Right. Yeah.
So, yeah.
Not an issue, guys.
And then just some things that we could go from here. So for example, implementing the heart rate sensor that we were looking at earlier. We didn't get to do that during this semester, but that's definitely something that we would like to do. Adding a camera to just like we were saying before, how if something pops up, the camera can turn on and see what's going on. Implement some front end things for the website. We already have some, but we want to, of course, make it as beautiful as possible. Working on the next case prototype, because this was an alpha prototype, and of course things went wrong. So making it better for next time, and power management on the collar. Just making sure that we have the right battery and stuff.
Well, right battery, and right now all the sensors are on all the time.
Yeah.
So like, we don't need to. If it's not taking a reading right now, it doesn't need to be on. But for something like this, we have more than enough battery. But if we're actually doing a long-term installation, a long-term application of the collar, then yeah, there would definitely need to be some management, some MOSFETs or something turning off power completely to the magnetometer, to the thermometer. The GPS has an enable pin, so you could disable it in that way, and stuff like that. Put the ESP to sleep when it's not being used. So,
some other things, maybe I wanted to work on the mesh network for the LoRa's, because now we have just point-to-point